Hi everyone, I'm here to solve this problem. 80 seconds from challenge problems and exactly from the 28th chapter. And there we have the figure I showed there, and there is the about capacitors this problem that begins charging after the switch closes. Switch closes exactly at time when it will be equal to the zero, and the goal is to analyze the circuit and derive the equation for charge over time. And also we should analyze this circuit and show that this equation that Q will be equal to this equation, and Q it means charge, and the Q maximum, there is the Q maximum will be equal to this. We should prove this. And first we will understand given circuit, and it shows, this figure shows that we have the battery with voltage, also resistor and capacitor, and also switch closes at when time will be equal to the zero, what we have mentioned already. And what happens when the switch closes? When switch closes, at that moment current will begins flow first from the battery, then will be through the resistor, and finally to the capacitor. And over time the charging slows down and eventually stops. And we are asked to show that Q over time will be equal to this equation. And in this problem we will use our Kirchhoff rule. Kirchhoff's rule. And what is Kirchhoff's rule? If you have kind equation, it says that the total voltage gain and drop around a closed circuit loop is zero. It means that the voltages that we have, we will minus them from each other, and at the end it will be equal to the zero. And what we write, E, it's voltage gain from the battery, what I have showed earlier, and current multiplied by resistance, it's voltage drop across the resistor, and Q over S, charge over capacitor. It means also voltage drop across the capacitor. And we have mentioned their current, and we know that current equal to the change dt over dt. And we will substitute this equation into this equation, this loop equation. And then will be E minus R multiply dq over dt minus q over c will be equal 0. And then we will rearrange gives in left side we will write dq over dt multiplying by r, and on the right side e minus q over c. And this is a differential equation. It shows how charge changes over time. And our strategy will be in this equation, in solving this equation, we will separate these two variables. Then we will write in this way dq. In the left side we will leave dq, and will be over q over c, right, equal to the dt over r. And it's like separate, it means left side and it means there. And then I will be multiply top and bottom by c. If we be multiplied by c, then c dq will be in top, and on bottom ce minus q, and it will be equal to the dt over r. And we will integrate both sides. And left side becomes ln c e minus q, and it will be equal right side t over rc plus constant. And how do we find the constant? We will use the initial condition. It means that when time will be equal to the 0, then charge will be also equal to the 0. And it means that ln ce will be equal constant. And we will plug back ln ce minus q plus ln ce will be equal t over rc. And then we will use the log rule, logarithms rule from mathematics, and then will be ln ce over ce minus q will be equal t over rc. Now take the exponent of both sides. Then we will write that ce over ce minus q will be equal e, and the t over r c will be in power. And we will flip both sides. Flip like change top and bottom. CE, flip it like, and CE minus Q, C over CE. There will be E minus T R C, and we'll divide by CE two of them, each of them, and there will be 1 minus Q over CE will be equal to the same thing. And then on left side, and 1 minus E minus T over RC. And after this, charge over time will be equal to the CE multiplied by 1 minus E minus 1 over RC in power. And we have shown in the given that QT will be equal Q max 1 minus E minus T over mean time, where Q max will be equal CE, and also mean time will be equal RC. And what does it mean? That at time, when time will be equal to the 0, charge will be equal to the 0, and as time increases, QT get closer Q max. The capacitor charges more slowly over time, and I think that it's all of my problem, from my solution, and I think it was understandable and simple. Thanks for watching, and goodbye.